Hey, welcome back, Ben again. Today we're taking a look how to install Tensorflow 2 and how to do some object detection. So to get right into this, the first thing we want to do is go to the official Tensorflow GitHub repo, and we want to clone this repository. This contains everything we need to do object detection and whatever else TensorFlow does actually. But for our purposes, we're focusing on the object detection, and everything we need is right here. So we're just going to grab this and we're going to clone it into wherever you want to put it. So I have a little place where I have to put my projects. And when you clone it, it's just going to make something called models because that's the base of this. So I recommend making another folder and then putting it underneath it. So we'll just call this like the TF2. That's good. So we're going to go in here and I'm just going to open up a command prompt and clone our repo. And that might take a minute because it's kind of a big repository. All right, now we finally have that downloaded. All right, so we now have, you can see it here now, it's appeared under our projects. We have models, and if you go into this, there's a whole bunch of things that we're going to be going through. But before we get into that, we need to download a few other things. So the next thing we're going to get is Protobuf, and we need that to install some of the Protoc files that are included. You don't really need to know what they are or what they mean, but we need to know how to install them. So to do that, we're going to go to this website, and I'm going to link all the addresses or all the websites I go to in the description. And I'm also going to have a GitHub repo that has a lot of the things that I do in there. So we need to get the version that goes with our platform. In my case, it's Windows. So get on here and click Show. And this might look different when you do it depending on when you're watching this. But what you want to look for is the one that matches your system. So I want the Protoc version whatever, Windows 64. I already have it, so I'm not going to download it again. But all you need to do is once you get it, unzip it, and we're just going to move it somewhere where we're not going to lose it. So I recommend putting it in your Python directory, if that makes sense. So I'll show you. I already have mine, but if we go to app data, and if we go back one and go to local, and we go to, where is it? Programs. This Python folder is where your Python versions are stored. So you can see I have 3.11, 3.10, etc. And this is where I put my download that we got. So once you extract it or unzip it, you're going to get this folder. So I'd recommend putting it in here. You can put it wherever you want. Just make sure you don't delete it. And you also know where it is. Because the next thing we're going to do is go into this, go into bin, and you can see we have a Protoc file. This is the actual exe. So we need to be able to call this command further on in the project. So we need to add this to our path. So what we're going to do is just copy this address that we're at. And we want to edit the path. So if you just type in path, you'll probably get it here. Otherwise, you can go through the control panel. And so it's going to be edit the system variables. And we're going to go to environment variables down here. And then here, you're going to click the one that says path. We're going to do edit. And you would just click new and paste that directory in there. I already have mine. You can see it on this one above. Python, that folder we were in, the Protoc, blah, blah. You can't see the whole thing, but it ends, there it is, it ends in bin. So same place as in here. Toss it in there. So now you'll be able to call this Protoc command from anywhere. So make sure you hit OK on everything. Yours might say apply if you're just adding it. It'd say apply right here. So OK, back out of that. Cool. So Protoc is set up and ready to go. The next thing we need is Anaconda. Anaconda lets you have little Python virtual environments, and this is going to make our life 10 times easier, so I highly recommend doing this, and I'm going to be using Anaconda for this. So you can just press this download button. Again, I'm going to have this link down below. And it's just your normal, regular installer like anything else. So go through the setup instructions. I believe there's an option that says add to path. I'd recommend doing that. So just make sure you download that. Cool. So once we have that, we can actually go into Conda. So I'm actually going to close my other one so I don't get confused. So once you're installed, you should be able to say Anaconda and open up a command prompt for Anaconda, specifically Anaconda. And you can tell you're in the right one because it's going to have this little prefix in front of your directory. So currently we're in the base environment. What we're going to do is we're going to make a new environment that's going to encapsulate everything we do so we don't mess up all of our external systems or anything else, and it's going to keep it all together, which is really nice. So we're going to create a new environment. So to do that, we're going to say conda create. You're going to do -n for name, and then you're just going to give it a name. So I'm going to call mine tf2, like that. And then you're also going to say pip and python equals 3.9, and this just tells it we're going to be using pip and we're using Python specifically 3.9. At the time I'm making this, most of TensorFlow 2, the dependencies that it has and the libraries require 3.9, or it's kind of like the middle ground of where everything works. So I recommend using this one. But if this one doesn't work, if you get install errors later saying like wrong version, you can change this to be a different version of Python. But as of the time I'm making this, Python 3.9 definitely works. So we're just going to hit enter. This might take a second. We're going to say yes, or Y technically. And this might take a moment. All right. And then it's giving us little instructions. So to activate it, we have to say conda activate and then the name you gave it. So that's what we're going to do. Conda activate tf2. And you'll know that has worked. That has worked if you get this little thing, this little prefix in front of it changes. So whatever name you set should now be here. So now we're kind of in our own little separate environment. Cool. So while we're in here, even though we just downloaded Protobuf separately and put it in our path, we also need to download it as a package just so that the environment and TensorFlow itself knows what we're talking about. Because for some reason they can't talk to each other, so we have to do it separately. And instead of doing pip install, we're actually going to do conda install. We're going to do conda install Protobuf. Now I couldn't tell you exactly why you can't do pip Protobuf. You can do it, but it's not going to work. For some reason, it just really... There's a couple things. We're going to do this another time too, where installing it directly into conda is like the more surefire way to make it to work because we're putting it into the environment itself. So by doing conda install Protobuf, we're kind of doing it as like the whole environment. So it just works better for whatever reason. I couldn't explain why it does, but it just does in over pip. Cool. So we got that. That's cool. We have our directory installed. So now we are going to navigate to that project we made. So tf2, I'm just going to copy this directory, and back inside of conda, I'm just going to say cd, paste that in there, and now you can see we are under that project that I made. And so next we need to go to models/research, just like that. And if you do a dir, you can see there's a whole bunch of things in here, which is good. That's what we're looking for. All right, so now we actually need to write a tiny little Python program that's going to take care of all the rest of the Protobuf stuff for us. So further in here, there under object detection, there's a protos folder, and it's full of files that have the .protoc extension. So we need to initialize those basically. So this little Python program, we're going to do is just going to go to each one and activate it. So I have this code off to my side, but again, this is going to be in my repo. So let me just get a new one and let me copy it over. I'm just using Notepad++ because it's pretty small. And I'm not going to go over it because it's pretty simple, but we're just going to go save that into our project. So where did I save it? PyCharm, tf2 models. Make sure you put it under research because that's where we were at. We were under models and then research. So just make sure you're putting it in the same place. So I'm just going to call this use protobuf.py. That's important. And you can see that worked as now everything kind of has the highlighting. Cool. So now that we have that, just for ha-has, I'll do a dir again. And you can see that we now have Protobuf, use Protobuf in here. Same if we go into our directory in here. It's in there. Great. So now we're going to run that script. So we're going to say Python use underscore protobuf. And then we're going to say object detection slash protos. Oh, it's not going to autofill for me. I'm going to say protos and then protoc. This is basically inputting the directory we're looking at. And then this is the command. The command is just protoc. So that's why we had to edit the path so that we could say this. Otherwise, you wouldn't be able to say protoc. So we're going to do that. There we go. Must have missed. And there we go. Shouldn't be any output unless something went wrong. And cool. So that's all set. Whoops. Okay, so now we need to copy a setup file. So if we go back into the File Explorer, we want to go into Object Detection, and then we want to go into Packages, and then TF2, make sure you're in TF2, and there should be one file in here. So grab this, we're just going to copy it, and we're going to go back. We want to be back under Research. Make sure you're in Research, paste that in there, and now back in our little environment, we want to say pip, actually, whoops, my bad, I'm going to say Python -m pip install period. This is just going to look for a Python program named setup, or I think they can have another name too, but it's going to look for our setup Python file. So we're going to hit enter, and this is going to take a long time. I'll warn you that right now. So I'm probably going to do a little time cut skip because this can take a few minutes. So I'll see you when this is done downloading. Alright, that's finished downloading. Took a couple minutes. And now we can continue. Cool. So we have that. We have to do another conda install because for some reason numpy is included in this but doesn't download correctly. You can actually see it right here. But you'll almost certainly get an error later for this numpy because for whatever reason the install of numpy that comes with this is broken. And I found that the best way to fix it is to do a conda install. So we're going to say conda install numpy like that. And it's going to ask us to confirm. Say yes. That'll take a second. Again, it's one of those things where it just works better if you do it directly into conda. I couldn't tell you why, but it solves a lot of problems. Alright, so we have that. So now we can actually test to see if everything is installed correctly. So to do that, there's actually a built-in testing file that they've included. So we're going to say Python object detection / builders, there we go, builders / is it gonna let me autofill? No, okay, my bad. Model builder, it's a long one, tf2_test.py, sorry, okay, there we go. And you'll probably see some warnings if you don't have a CUDA GPU. I do not, that's okay. And you can see these tests are kicking off and running. Take a couple of seconds. Nothing seems to be breaking, so that's always good news. And there we go. Okay. If it ran successfully, you should see something like this. Ran 24 tests. The number of tests may be different depending on when in time you're doing this. It might change, but you should see a bunch of runs and OKs. And as long as there's no glaring issues, like no errors popping out, we should be okay. So now we're going to move over to an IDE and, well, technically we've finished the install. And since this has worked, we have successfully installed Tensorflow 2. So congratulations if you made it here and everything worked. So just as an example, I'm going to run through one of the example scripts that lets you test it and actually do some object detection on some real images. So I'm going to open up a IDE. I'm going to use PyCharm. You don't have to use PyCharm, but I like it, so that's the one I'm going to use. And the rest of the tutorial will be more specifically towards that, but you should be able to continue even if you're not using PyCharm specifically. And I'll show you how. Cool, so let's go to our project. So this is my project. I'm just going to go up here and open this as a project for PyCharm. And I'm going to trust it. And again, you could do this in VS Code or whatever else you want to use. I just find PyCharm to be easy. All right, so we're in here. And what we're going to do is that, again, PyCharm specifically, I'm going to add an interpreter. And you can actually add the conda environment we were using already, which makes it really nice because we don't have to go back and forth between that terminal and here. We can do it all inside of PyCharm. So if we click on conda environment, you should be able to do existing environment, and you can actually see the one we were using is here. You can see environments TF2, might be kind of small, but it's right there. If you don't see yours showing up, you can use the dots to browse for it. This path should be very similar. If you installed it in the default location, users, your username, Anaconda 3, environments, and then you should be able to click on the one that you had. So I really like that PyCharm has this feature. So we're going to do that. And now one of the downsides of PyCharm, or this will probably happen in VS Code too actually, is that it's going to like basically kind of configure itself to understand all the libraries and dependencies we have. So you can see down here in the corner we have updating skeletons, and this might change. This takes like 5 to 10 minutes, which is kind of annoying. So yours might be similar once you do that. So I am going to cut the video and I will join you guys back when this is done loading. Okay, cool. Okay, cool. Looks like we have finished doing all those dependencies and updating. So now we are ready to do some detecting. So I'm going to open up, so you can see the directory here. We're under models. We're going to go into research, and then we're going to go into object detection. This folder is kind of where everything happens, as you might have seen so far. And I actually have a couple of scripts I'm going to move over. So I'm going to bring these two over and I'll show these to you guys. I'm just going to paste these in here. Click OK. Don't need to add to GitHub. Okay. So I've pulled these scripts from another example online from, I think his name's Gilbert Tanner. I'm definitely going to link him, and actually the repo I'm going to share with you guys is a fork of some of his work. So big shout out to him and his tutorial that he wrote up. A lot of this is actually based on that, but I noticed that there were some discrepancies. So the thing with like numpy and like Protobuf, he doesn't really explain how to do that or potential errors you might have. So I thought it would be a good idea to kind of elaborate that on a video. So again, I'm definitely going to link all of that, and big shout out to that code. So, and again, since this is mostly an install video, I'm not going to talk much about what this is doing, as for a lot of this, we don't really need to understand the code, as a lot of this is just setting up the models and whatnot, but I'll show you guys how to put in some of your own images in your own model. So to start, we're going to use this model downloader, and all this is going to do is download a model for us. So I'm going to open our terminal real quick because you can see I'm missing wget, and in here I'm actually going to say conda activate, although I think it's activated by default just in case. df2. Yeah, I think by default it's activated if you do the method I did. So we're going to say pip install wget, and wget's just a library that can down links from online. It looks like that worked. So this download link is from the model zoo, and this is where TensorFlow has official models that you can use. I don't want to use this model though, so I'll show you guys how to get different models. So if we go to here, so this is the detection model zoo. Again, I'll link this below. These are a bunch of models that you can use that are pre-trained, which is awesome to use. And they're kind of sorted by speed and this measurement. I'm not really sure what that measurement stands for, but it's kind of like the performance measurement. So if you're doing this and you don't want to use the same one I'm using, you can kind of you can make a comparison of the speed trade-off or the performance trade-off, because you'll see some of these run really slow, but they have a much higher rated performance. So you can see this one, it takes a lot longer, like 133 milliseconds, but it has a 48 score, where some of these take like 6 seconds, but their scores are much lower. So the one that we're going to use, this is SSD MobileNet. This is a good standard one to play with because it's pretty fast and it also works pretty well. So this is a good one for us to test with. So to download this model, we're just going to right click it on this link. We're going to copy the link address. We're going to bring it back over here. We're going to paste that in, and we're going to copy this last half, and we're going to put it into this. Whoops, I missed the F. This second half of the program just unzips the file we get. The file we get is a tar GZ, which you can't unzip normally on Windows. You have to use a tar file because it's a special thing. So all it's going to do is it's going to extract that folder and just put it into our directory. So let's run this. If you're not in the IDE, or if you're using a different IDE, you can also just run this in the terminal by just saying Python model downloader after you've edited it wherever, but I'm just going to run mine from right here. But again, you can run it from the conda terminal if you want to also. And we can see that finished. Some of the bigger models take a lot longer to download, and you don't really get any message here about download. So don't be afraid if nothing's really happening for a couple of minutes. If you download a different model, it'll either time out or actually download it. And you can see on the side now, we have SSD MobileNet down here. So it downloaded the tar, and then it extracted it into this folder here, which is what we want. Great. So now that we have that, we can open up this other file. So I've made a couple edits just for the sake of this tutorial. Specifically, I removed some of this, and I made it so that we can actually view the pictures. Because technically, this was originally made for a Google Colab or a Jupyter Notebook, and the matplotlib doesn't have like a GUI feature. So just to make it easier, instead of trying to show it, we just save the figure to an outputs folder, and we can view it after we run it. So that reminds me, we actually need to go to our side here. So under object detection, let's make a new directory. We're going to call it outputs. I mean, you can call it whatever you want. That's just what I used here because I said we're going to save it in a folder called outputs. And to run this program, we have to, why did it jump? We have to tell it a couple things. Let me just paste it in here. So we're just telling it the file. This is what I think this, since I copied this over, this is actually wrong. My bad, let me fix that. So the first one's just the name of the file. The second is the model. So you can see I have that model already in there. What is this? This is called detect _ from image. Just like that. So you see -m is the model we want to use. Just make sure you do the /saved model. If we go to this folder over here where we have it, you can see another folder, saved model. And what this program is looking for is technically this saved model.pb. So we just need to tell it to look in this folder. We also have a thing for labels. And these labels are what's going to be the thing that shows up on the screen that says what each object is. So we can get that from data. And there's a whole bunch of different labels in here. For our purposes, we're just going to use the MS-COCO label map. And that's just going to be basically all the labels for normal everyday objects. And then this is going to be where our test images come from. And you can see we also have a test images folder in here. I'll actually open that up so you can see what it is ahead of time. I think it's like a dog and stuff. Yeah, so these ones are some dogs, beach picture, and some wood shop. Cool. So we're going to run this. Oh, whoops, I messed up. It says detect from image.py cannot be found. You know why? I'm in the wrong directory. Silly me. We need to, this is the whole idea of everything happens under object detection. Of course, I didn't put myself in there. So we need to go to CD, models, research, object detection. There we go. There we go. My bad. Again, you may see some errors about CUDA if you don't have a CUDA GPU. And again, that's fine if you don't have one. Just like me, we're running this all on CPU. Depending on the model you use, this will take longer. Like we saw on that page, you could see like the millisecond reading. So this one's pretty fast, so it shouldn't take too long. And that's done. So we told it to save in outputs. And you can see now there's some things in our output folder. So we're going to view it in the Explorer though. Test images, go back one on outputs, and you can see that these pictures are now a little different. So we're detecting some dogs, seeing a person in the background. Very nice. This one has a lot of stuff going on. We've got some kites, people, lots of things going on. So cool, this definitely worked. This one's a little low res once it spits it out, but I can tell this is a person. So awesome, we have successfully detected objects using TensorFlow 2. And you know, the sky's the limit from here. And that original repo that we have, he also has, Gilbert Tanner has some examples on detecting from a webcam that you can do also that's very similar to this, or I might make a video that also does it. So yeah, definitely let me know if you guys want to see some more things involving TensorFlow 2 object detection. We could do training a model from scratch to detect custom things. We could do like the webcam if you want to detect from a video instead of pictures. You know, let me know in the comments, and that's all I got. So if you liked the video, like I said, leave a comment, leave a like, subscribe. Thanks for watching, and I'll see you in the next one.